Rich, would you mind turning off the lights for me, please? And thank you. And I have my props here. In a minute, I will. You'll have some fun. It's almost like a magic show, except for there's no magic. All right. So at the front here, I want you to write down to be accurate. Right? Or we say something is accurate, and we'll write this down one more time. We need a standard unit, right? We want a standard unit of measure. Okay, so that would be your centimeters, inches, miles, grams, milliliter, ounces, you name it. Those are all standard. No matter where you go, they will be recognized, and it's the same everywhere. A gram here is a gram in the Philippines, India, China, no matter where you go, right? And you want an appropriate scale. Right? So millimeters, thickness of book, right? Distance between cities, probably kilometers, right? And so forth. Distance traveled from, I don't know, some of you probably from home to here, some of you probably just walk, right? So it might even just be a couple hundred meters, right? Yards, depends. So that's what we talked about. So I thought, hey, let's throw that in there. And this is the next one that I really want you to pay attention to. Precision. Okay. How exact the measurement is. Like how exact, how can that be done? And there are three ways that you will be given the precision in this unit. Three ways. If it's just a number, or value given. Okay. Number or value is given. So example, let's say a container has 355.27 milliliters. What would be the precision in this particular case? What would we assume about the measuring device that has been used to come up with this measurement? We are assuming that it is precise up to this last digit right there. So we put a 1 down and we fill everything in with zeros. Okay, so this value right here gives us the precision. Same units, that's the precision. And do you remember uncertainty? What's uncertainty? How do you find uncertainty? It's always half of your precision. That's what uncertainty is. I will write that down on the margins later on. So that'd be 0.01 divided by 2, which is 0.005, plus or minus. And you're like, what? Why is the uncertainty? Like, why do we need to? Think about the wording. You're uncertain to a certain degree, and we always take half of the precision because you are guessing at one point. The next one, the second way that you might have to figure it out is markings. Markings or increments. So let's say you have a beaker, right? and on the sides you have markings, right? So I'm just going to say, I'm going to make 3 markings like that, and we're going to go 100, 200, 300, and somewhere on there you'll say this is milliliters. I'm sticking with milliliters for now because that's the first number. So if you have something like this, what is the precision of this measuring device? So now you actually have the measuring device given to you. How precise is this thing? How would you know? You have to figure it out. How much are you going up by? It's 100, right? And then another 100. So how precise is this? Down to the nearest 100 milliliters. Down to that's the precision of this measuring device, right? So what's the uncertainty? This one is easy, right? 100 divided by 2, that'd be plus or minus 50 mLs. You're kind of gonna guess in between 50 ml. And you're gonna tell me, no, Mr. Erickson, I'm smarter than that. I know that if the liquid is right about here, I will know that that's 150. That's not the point. The point is, think about the definition of precision for us is 100 milliliters at a time, and therefore there's an uncertainty of 50 milliliters. Okay, next. Words. Yeah, just like that, words. Ruler is marked to the nearest inch. Like if you have something like that, to the nearest inch, they're telling you that this goes up by 1 inch at a time. Nearest inch. So precision therefore is 1 inch. Uncertainty therefore is 1 divided by 2. That's 0.5 of an inch, plus or minus. If it said it's marked to the nearest quarter of an inch, then your precision would be 0.25 of an inch or 1 over 4, and you go with it like that. So 3 ways of coming up with the, but I'm going to trick you a little bit. I think you're smart, right? So that's why I like to trick you every once in a while. And the word tricking is probably not the right, I just want to challenge you a little bit, particularly with the middle. So I'm going to break this down into 3 columns like that. Let's say we're looking at a gauge, right? And right down at the bottom, you're going to put PSI. Anybody know what PSI is? Where do you, yeah, pressure in the tires, right? It's pounds per square inch or something like that. PSI. So, but I'm going to add a little twist to this. Just write this down first. So just do your 0, 10, 20, 30, 40. Try to space them out as best as you can. It doesn't have to be fancy, right? So now you're going to grab your pencil and split every one of those with a smaller mark halfway between each increment I just gave you. You're going to put down markings again. That actually looks pretty good. I'm pretty proud of myself there, because I'm not really good at anything artistic. I'm not really good at. What's my precision here? Would you think 10? Because those are the numbers that are on there. You might be tempted. It's actually 5. It's actually 5. So it's 10, but because of this marking, you got to watch out, like what is the smallest marking that this is going up by, the smallest increment. So it's actually 5 psi. Smallest increment. The smaller the increment, the more precise you are, guys. The smaller, the better, right? So you can be more and more precise. If I were to go back in here, I'm not going to do it because it's going to mess everything up. You can't do undo on this one, right? But if I were to put markings yet in between, then you would have quarters, right? So that would be 2.5 psi, right? That would be the precision. So that's your precision. Uncertainty, 5 divided by 2, which is 2.5 psi. So plus or minus 2.5 psi. If I can summarize precision, this is it. It could be an actual, I will give you this on the AC today. There could be a picture of something. There could be just a measurement, or it could be the words tell you what it's going up by. Yeah. How much does each marking represent? Is that another way of looking at it, right? Like if you should be able to say, okay, if it's 5, then let's test it. 5, 10, 15, 20, right? It's working out. 5 works out. Another way you can do it is like, what's the difference, right? Between 0 and 10, it's 10. 10 divided by 2, right, is 5. Let me give you another example here. Let's say hertz. I'm going to do something like a weird, or decibels. 50.49 decibels. So the units don't really matter. Just go with the units that you're given, right? Decibels, what is that used for? Sound. Some of you have like a radio, right? If you turn down the decibels, minus or plus, actually. What would be the precision and the uncertainty if I asked you for it? 0.01. So you got to watch out, right? That is the precision right there. 1 like that. So then you fill the rest in with zeros. You don't need to worry about the zeros on the whole number side, right? So that's your precision there. And uncertainty, just take that and divide it by 2. Right? And you see a pattern that the number of zeros increases, and then you get a 5 like that, plus or minus. So if I asked you for the measurement, right? If I asked you to state measurement plus or minus uncertainty, right? If I asked you to state the measurement with its uncertainty, you go through these steps, and then you write down 50.49, the actual measurement you started with, and then you just go, it could be over or under by 0.005. So you go through these steps, you figure that out, and then just tack it on to the measurement, and you're good to go. So if there would be a gauge here, like if I had actually put down the little arm, right, you would have to read it. You have to be like, oh, it's 20 and plus or minus 2.5 psi, right? So it varies. The applications vary, but the more you do these, the better you're gonna be quite fast at answering these. Okay, I'm gonna give you a little bit of a show here, the best I can do, because I find that this unit, just like that, is a bit dry. So I don't know what I'm going to start with. I think I'm going to start with my voltmeter. Put it to the test here. Let's see. See how many volts come out of me. Nothing. All right. Anyways, so a regular a AA battery. What's the voltage on that? Can you see that? It's hard to see. It's 1.5, right? It says it right there. 1.5. So if I were to measure that, let's see. You think it's going to be exactly 1.5? What do you think? Let's see. 2. Why is it saying 2? What's the precision of this thing right now? 1 volt, right? It doesn't know any better. So it's 2. So what if I increase the precision? Watch this. I'm going to keep this on here. Let's see if I can multitask. There you go. Now this is now a bit more precise. It's 1.6. So it was rounding it to 2 before because it's like, hey, I can only give it to you to the nearest volt, 2, right? Now it's 1.6. Let's increase our precision even more. It's actually 1.61, fluctuating a little bit, right? So that's what's happening. The more decimals in this case you introduce, the more precise this thing becomes, right? And would you know that you can actually go into infinity with precision in this case? You could keep adding and adding and adding, but at some point you're just like, this is ridiculous, right? Like we don't need it that precise. For us, this is good enough, right? Okay, so what happens to a battery as you use it? What happens to the voltage, you think? It drops to a certain degree where whatever you're using it for, it's no longer. Like a clock like that, you'd be surprised how long it can go before it dies, right? But then if you have a flashlight or something, it starts to not do its job anymore because you can actually see how it's dying, right? So poor battery, right? Either it works or it dies, right? Nothing in between. And then look at this one. Have you tried putting this on your tongue? I don't know if your siblings ever tricked you with that, right? Hey, put this on your tongue. It stings pretty bad. It's not going to kill you, but you're gonna feel it. 9 volts, yeah. I've done it, yeah, when I was younger. Don't recommend it. Okay. I don't want your tongue on, so just go get your own. Okay, so it says 9 volts. Let's see. 7.27. So it's because I've used it already, right? So watch, let's decrease precision. What would it be if I drop a decimal? Yeah, it's going to go 7.3 because it was 7.27, right? It bumps that, fluctuates a little bit. If I just go to 1 volt, like nearest volt, it's just going to say, hey, this is 7, right? So that's something to keep in mind. Okay, you want more? Don't get too excited. It's okay. It's okay. Okay, this one is tough to make it work on the to make it show up on the camera, to be honest. Yeah, that's always the problem. Yeah, but let's try it. I know that it works at one point, but let's weigh something. Let's weigh this battery. I'm going to change the units. I'm going to change the units. This is grams now. Can you see that? Hold on, hold on. This is always a tough one, but I can make it work. Watch. It's going to work. Maybe not. Right there. Anyways, right now it says 45 grams. If you can't see it, I apologize. That's the best I can do. It says 45 grams right there. But I can also change the units on the scale. And right now it's in kilograms. It's 0.045 kilograms. No, there's no way you can see that, yeah. Bad example. I managed to get it to work once, but I'm not going to use it because it's not working very well. What about this? This is a thermometer. Yes. What's so interesting about this one? Is there more than one unit on it? There's Celsius and Fahrenheit. You see that, right? So what would be the precision if I said, hey, to the Fahrenheit? What's the precision if you use Fahrenheit? It's 10. Do you see that it's going up by 10? What about Celsius? That's a, it's, is it going up by 6 exactly? Doesn't seem to. So this is not a very good example. I wouldn't do that to you. It has to be the same amount, right? But it is about 6, right? You go from to 66, that should be 72 technically, then it goes up by 6 again. So anyways, that's a thermometer right there. And then there's this one here. There's another thermometer. I barbecue a lot, so I use this all the time. This would be, what's the precision of this right now? 0.1. Even if there's a 0, guys, this is actually, see how it's going up by 0.1 at a time every. So this is also a 0.1 of a Fahrenheit, but I can change it to Celsius, and it's also 0.1 of a Celsius. That's the precision of this, right? So, and it's actually pretty cool. See, you can tell that it's going up by 0.1, right? Or down. So if I touch it, let's see, goes up, right? Maybe I have a fever, should go home. Actually not feeling so good, guys. Anyway, so that's that. What's the precision of this? Before I give you the AC, what's the precision of that? It's 50, you see it? It's going up by 50, pretty easy. What if I'm not going to do it because my wife won't be very happy. With a Sharpie, if I with a Sharpie went and split everything in half, that'd be 25 milliliters, yes, immediately. So don't look at the numbers, look at, obviously the numbers help you, but the markings are really what you're after. What about this? Oh, Mr. Erickson, that's tricky. Look at the ounces. 2 ounces, 4 ounces, 6 ounces. So if we went by ounces, the precision is 2 ounces. Okay, you're good, and you're smart. Quarter. So what about this? Quarter cup. Like if we go by cup, quarter cup, half a cup, 3/4 of a cup. So the precision here, quarter of a cup. Yeah, 1/4 of a cup or 0.25 of a cup. That's fine. Right. And maybe Morocco will say World Cup. Right. That's the precision of Morocco. Who knows? I think Morocco at this point. I don't know. I'm just. I always like the underdogs. I always do. So Brazil is out. Brazil was my horse, and that one is now it's out, right? So that's it. What's the precision of this thing? If you go by grams, this one is tougher. Let me see if I can. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 markings between 0 and 200, right? Would it make sense that this long one here is 100 then? So let's try something. 25, 50, 75, 100. It's 25. So what you can do, here's some strategies. I'm trying to help you guys. You can count, right? 1, 2, you can count how many spots are there from 0 to 200, for example. What's 200 divided by 8? Because there's 8 spots, right? 1, 2, 3, 4, 5, 6, 7, 8. 200 divided by 8, right? 25. So that's another way of doing it, right? That's the precision. We see, I'm focusing on precision because once you have your precision, you have your uncertainty. You just split that in half. Right? So I'm focusing on precision because once you got that, you know your uncertainty. That's my show, guys. Thank you. Thank you. There you go. All I've got. And I hope that helps a little bit, right? Like, because Is this a bit dry? Like some of the examples they have, I just don't like them, so I kind of tweak it a little bit. Okay, so I'm going to give you the AC. I'm going to pause this here. Smash the like button. Hit subscribe. I'm on my way to 70 subscribers. All right. Explain the following measurements would give an accurate measure. Why or why not? Use the length of your foot to measure the width of the gym. You can actually say not accurate right away, and then tell me why. Not a standard unit, right? Length of the foot. Length of the foot is not a standard unit. Done. Right? If you talked about, like, technically the scale would be okay. Like using your foot to measure the width of a gym, it's not ridiculous or outrageous. It's possible. So next, a teaspoon to measure the correct amount of baking powder for a chocolate cake. Actually, it is accurate. I may have not referenced it, but a teaspoon is technically a measure when it comes to baking, right? Unit is standard, right? Teaspoon. And scale is appropriate. For this application. Right? Using a 5-gallon bucket, probably not, right? Using a 5-gallon bucket to measure, no, not a good scale. Okay, so I would give you 2 marks for each actually. 1 mark for stating whether or not it is, 1 mark for the correct justification. You will not get away with just saying yes or no. Okay, that would not give you marks there. So 2 and 2, right? Circle of measurement that is more precise. So if the units are the same, you got to watch out. If the units are the same, more decimals win. Or wins, I should say. Right? That's more precise. Both are in centimeters, has more decimals, so this one is more precise. Between these two, what would you pick there? Millimeters would be. Like it's a smaller unit, right? It always wins. Yeah. Yeah. And between these two, it was hard to see, right? But this one goes up by 50. I don't know if you noticed that. And this one goes up by 100. So it's actually this one. This one is more precise. 1 mark for each. So that's 4, right? 1, 2, 3, 4. And plus 4 up here. So that's 8 for this back side. And now the back here, state the precision and uncertainty in each case. In this case, the precision is 0.1 centimeter, 0.01 centimeter, I should say. The uncertainty is this. I will give you 2 marks for each. 1 and 1. Let's put it this way. If you get this wrong, but you split this in half to get your uncertainty, I'll give you 1 mark. The precision here is 0.1 of a kilogram. Uncertainty is half of that. And so it's this much of a kilogram. 2 marks for that. What's the precision on this one? 50, right? You're going up by 50 from marking to marking, not from number to number. It happens to be that the markings are in line with the number. So this would be 50 milliliters. And so it's 25 milliliters for the uncertainty. Just half off. Yeah. Half off for this whole page, half off for missing units. Just 1/2 mark deduction, that's it. But you should remind yourself to add that every time, right? So backside, this backside is 6, right? 6 for, no, yeah, sorry, 6 and 8. 6 and 8. So that's 14. Mark out of 14. And make sure your name is on there, right? And pass it forward. We will continue. It's like me with my phone, like I'm recording my kid, right? Oh, that's good. It's like, oh, what? It wasn't recording? Missed the whole thing. Anyway, so yeah, so max, min, and range come from this, right? All right, let's. I want you to take a few minutes. I'm gonna take it back in like 7 or 8 minutes, but I want you to. I asked you to actually get this started yesterday. So state the precision and the uncertainty for the following scenarios. There's also a picture on the side here, and I also want you to try the back side. Goes all the way down to question 12, and this one is a bit challenging, but you can do it. And then I'm going to teach you something new today. So make sure you take the time just to do it quickly. It shouldn't take you that long, right? So this page to the bottom and the back side, I'll go over it and then I'll teach you the new concept. If you did as much as you could, perfect. A ruler marked in millimeters is used to measure a pencil as shown. What would be the precision of this ruler? And some students might be confused, like, well, I don't know, there's like, right? It says marked in millimeters right there. So you didn't even have to re-look at that. The markings tell you what the precision is. And what you could have done is 0.1 of a centimeter if you wanted to, but I think it's easier to just say, right, plus or minus 0.5 millimeter. And I want to use this question to also already get you ready for the next thing, which is measure it. Like state the measure of this pencil with its uncertainty. So you just try your best, right, to line it up. 6.2 centimeters or 62 millimeters, right? So I would say the pencil measures 62 millimeters plus or minus. What's the uncertainty? We figured that out, right? 0.5 millimeters. So this is the measure plus or minus uncertainty, right? So you gotta watch out for that. In this case, really all you needed to do is this, right? That's what all of these questions are asking, to figure out the precision and uncertainty. Odometer, it says nearest kilometer. That is your precision, right? And therefore your uncertainty is 0.5 of a kilometer, so plus or minus 0.5. The plus or minus doesn't need to be there if you're just stating the uncertainty. It does need to be there when you're stating the measurement with its uncertainty. I tend to just do it, right? The outside temperature recorded is this. So this is when you're given a number, you have to go by it, right? So this is 0.1 degrees Celsius is your uncertainty, right? It's 1 decimal. It's to the nearest tenth of a degree. That's 0.05 degrees Celsius. Okay. Harpreet says it took him about 5.25 hours to drive from Vancouver to Kamloops. There is where we get our precision from. 0.01 of an hour. And therefore my uncertainty is, which is weird, right, to do this? But that is what you would do in this course, plus or minus 0.005 of an hour. Got it? Hopefully you're trying this, you're catching things, right? Runa used a meter stick marked off in centimeters, so there's that markings, increments, all of that tells you precision. What's the precision? 1 centimeter. Uncertainty is plus or minus 0.5 of a centimeter. Odometer, to the nearest, it measures distances to the nearest tenth of a kilometer. And here's where you need to be, I guess, good at your place values, right? You could say this, 1/10 of a kilometer, that's fine. If you're like me, I don't like fractions that much. They're okay. Try to avoid them. So there's 0.1 there. That's what this is saying. They're both equally okay to use. Sorry, this is uncertainty would be half of that, which is 0.05 of a kilometer is the uncertainty in this case. Timing is a vet nurse. Dog's temperature is this, and Celsius with the precision. I think at this point you're like, I get it, just move on already, right? I hope. But that's the uncertainty there. What's the precision and uncertainty of this measuring device? This should have said inches. That is my bad, but I'm guessing you would have determined that, right? The first giveaway is if it's anything metric, there should have been 10 in between, right? This doesn't have that. Precision of this would be, let's count 1, 2, 3, 4, 5, 6, 7, 8. So from 0 to 1, there's 8 spots in between. So actually you can say this, the precision is 1/8 of an inch, or you grab your calculator and you just go 1 divided by 8. If you're in the shop, you knew this already, right? 0.125, 0.125 of an inch. Both of them are acceptable. For uncertainty, what's half of 1/8? 1/16. Think of it this way. You're taking these 8s and you're splitting them in half. You now have 16. So it's actually 1/16 of an inch, or you split that in half. So I'm going to just divide that by 2, and that's 0.06. Do not round in this unit. I should have mentioned that right off the top. We don't round in this unit. We use as many decimals as possible. Okay, and state the measure of the string with its uncertainty. So what would you say? 1 for sure, right? 1 inch, and how many eighths? 1/8. Would you say closer to 2/8 or 1/8? I think it's closer to 2/8. So 2/8, and what is that as a? This is where you should convert. 2/8 is 1/4, right? 1 1/4 inch. Plus or minus, what's the uncertainty? We already determined that here. It stays the same. If you're using the same ruler, the uncertainty stays the same. You choose which one. I'm going to pick this one. So plus or minus 1/16 of an inch. This is the answer to that question. Right? State the measure of string to the nearest. Oh, it's the same. This one is the same. 1 1/4 inch plus or minus 1/16. That one is the same. But what if it's? We're going to scrap this one. We're going to go straight to this one. Measure the length of the string to the nearest half of an inch. Nearest half inch. If you have a highlighter. If we were to go by half-inch increments, we would go half, 1, 1.5, 2, 2.5, 3, correct? That's what they're saying. If you needed to say, let's imagine for a second that the other markings aren't there, just to highlight it once. How would you state this measure? Would you say that it's 1.5 or just 1? Which one is this closer to? I would say it's closer to 1. Right? Like if you look at the string, it's not quite halfway in between, it's closer to 1. So it's just 1 inch plus or minus 1/16 of an inch. So if you go to the nearest half of an inch, we would say 1. Right? If it's to the nearest 1/8 of an inch, we would use 1/4 because 2/8 turn into 1/4. This one you don't need to worry about too much. I will have some measurement, but quite often it's going to be in metric. Some imperial, but not all. Okay. Before we go, I need 5 minutes, and then you have the last 4 or 5 to yourself. Okay. So follow me here. Where are we? Yeah. On page 85. Okay, just go to 85. It's not that complicated. Just make sure you have this in your notes. All right. Genevieve is mixing juice in a jug marked in quarter liters. It's already in bold, but I want to highlight it. She measures the amount of juice in the jug to be 2.5 liters. I'm going to circle it. It's important. Write the measurement of the juice in the jug in the form measured value plus or minus the uncertainty. So obviously you would say the measured value is 2.5 liters, correct? And normally we would go by this to figure out our precision, right? This trumps everything, right? This is where we get our precision from. Your precision is in quarter liters. So it's a quarter of a liter or quarter liter like this, right? If you divide that. And from here, I get my uncertainty from that. I'm just going to go 0.25 divided by 2, which is 0.125 of a liter. Okay. So the uncertainty came from here. Okay. So we're going to go plus or minus 0.125 of a liter. Do not get your precision uncertainty from the measured value. You get it from this. Okay. What is the smallest and largest possible volume in liters that could be in the jug? I'm going to go largest first. Largest would be 2.5 liters plus. You take the plus, right? Because obviously it's going to go up. You come up with a number there. Smallest, you take the 2.5 liters, you subtract the uncertainty from it. And you come up with a number there. So you grab your calculator, 2.5 minus 0.125, that is 2.375 of a liter. Did I go minus? Sorry. This is actually 625, right? This is 2.375, my bad. This would be 2.6625. There we go. And so this would be the max. This is known as our max. This is known as the min, right? In this case. What is the range of volume in liters that could be in the jug? The range is max minus min. So it's 2.625 minus 2.375. And the answer will be 0.25 of a liter. There's a difference of 0.25 of a liter between the greatest amount in there and the smallest amount in there, in that jug. Okay, I'm going to leave it there. For tomorrow, just make sure you know how to get the max and the min, review how to get the precision and the uncertainty. There are 3 scenarios that could come your way, guys. If you have, can I say one last thing before you pack? If you had all 3 given at the same time, this one would always trump everything. Okay, word, say word, right? I don't know. Something cheesy to help you remember, right? Word, that if it says mark to the nearest something, that trumps everything else. Okay. Okay, guys, thank you.